Okay, so we have a quick review for ranking cycle bago tayo mag-solve ng problem, no? So, in this time, makikita nyo yung typical components of a simple vapor power plant. So, we have a boiler or steam generating unit on this side. And then we have the turbine, we have the electric generator, we have the condenser, we have the pump, and we have the cooling tower. And of course, we have stock, no? So, i-discuss naman yan maya-maya. Okay, so we have the ranking cycle. So, yung ideal nating cycle was supposed to be Carnot cycle, but still meron siya mga impracticalities. So, to solve that, no? At saka ideal naman yun, wala talagang existing na ganung cycle. To solve that, we have to superheat the steam coming from the steam generating unit or the boiler, and then condensing it completely in the condenser. Thus, the creation of the Rankine cycle, which is the model for the simple steam power plant. So, yung Rankine cycle natin, tinatawag siyang SPSP cycle, no? So, we have a cycle. So, SP, SP. So, malalaman natin kung bakit. So, first, I'll be dealing with ideal. So, ibig sabihin, there are no internal irreversibilities and consists of the following four processes. So, if I'll be using this diagram, no? So, this is the boiler. Point one is between the boiler and the turbine. Point two is between the turbine and then the condenser. And point three is between the condenser and the pump. And lastly, point four is between the pump and the boiler. So, iba-iba kasi, no? Depende sa textbooks or kaya reference na ginagamit mo. But in this case, ito yung gagamitin natin so that hindi ka mahirapan sa mga uh, review materials, as well as books na ginagamit natin, especially in the school, no? So, we have SPSP cycle nga siya. So, we have process 1 to 2, 1 to 2. O, ito yun, no? So, this is reversible adiabatic expansion in the turbine or steam engine. So, yung ating steam generated from the boiler, exit siya, and then papasok dito saan? Sa ating turbine. At point 1, steam turbine, no? Naiikot siya na mass of steam. Okay, at point 1. And then, magkakaroon siya ng expansion. Ideally, at S is equal to C. So, constant entropy. No? Kaya siya reversible adiabatic expansion or isentropic process. So, ibig sabihin natin, in this case, S at point 1 is equal to S at point 2. So, ayun, no? And then, ano mangyayari dyan? So, once pumasok na yung steam dyan, with the energy, no? Mataas na energy content, so, magkakaroon ng transfer, no? So, from heat to mechanical, iikot itong mga blades sa turbine and then mag-generate tayo ng work. Now, once na na-utilize na yung energy, lalabas na siya at point 2, okay? At point 2, no? So, ano nangyari? Bababa na yung kanyang pressure. So, anong mangyayari dyan? From point 2 to point 3, papasok na siya sa condenser na tinatawag. So, process 2 to 3 is constant pressure transfer of heat in the condenser. So, we have P is equal to C. So, S is equal to C, P is equal to C. So, ano ibig sabihin nito? P sub 2, pressure at point 2, is equal to pressure at point 3. At meron daw transfer. Ano mangyari? Magkakaroon ng rejection. Rejection of heat. No? Okay? And afterwards, lalabas siya at point 3 and then yung steam natin papasok naman sa pump, no? Okay. Ano meron sa process 3 to 4? So we have reversible adiabatic pumping process in the feed pump. So again, this is S is equal to C. So ibig sabihin, S3 is equal to S4. Okay? And then, afterwards, pagkalabas ng steam sa pump, no? After the process of reversible adiabatic pumping, pabalik na siya papunta sa boiler. Again, meron itong constant pressure transfer of heat. So, this is P is equal to C. So, we can say that P1 is equal to P4. So, ayan, no? SP, SP. Okay? So, again, parehas lang naman. So, we have boiler. Again, we have heat added. O, pwedeng heat added yan, QA. Okay? From point, lalabas si steam. Again, may umiikot na steam dyan. Papasok si steam dito. Lalabas, ay, painitan, then lalabas. Point 1, then papasok siya sa ating steam turbine, no? So, this is S is equal to C. Again, S1 is equal to S2. Then, may utilize sa energy. Magkakaroon ng work generation. Then, at point 2, papasok naman siya sa condenser. So, dito magkakaroon ng heat rejection. Ayan, QR. And this is P equals to C. So, ibig sabihin natin, P2 is equal to pressure 3. Constant yan, no? Now, pagkalabas ng steam sa condenser, pasok naman siya sa pump, no? Okay, so sa pump, magkakaroon ng work ng pump para ma-increase yung pressure ng steam na kailangan para bumalik siya dun sa boiler. So, again, this is S is equal to C. So, S3 is equal to S4. And then, pagkalabas ng steam sa pump, babalik na siya sa boiler. Ito ay P is equal to C. So, we can say that P1 is equal to P4. Now, if we plot natin yan sa PV diagram, so ito yung ating saturation dome. Ito, itong curve na to. So, at point 1, no, ideally, no, ano ang process natin dito? Kasi ang daming 1. So, ang process po natin dyan ay yung 1, double prime, 2, double prime, then 3, then 4. Ito po yung ating ideal Rankine cycle, no? So, at point 1, double prime, expected na siya ay dapat maging superheated vapor. Bakit kaya superheated vapor? To avoid moisture entering the turbine. Kasi makakasira yun sa mga blades ng ating turbina, no? And then, at point 2, tama, ideally, from point 1 to point 2, so nasa loob siya ng saturation curve. At point 2, double prime, this is wet vapor mixture. So combination siya ng steam and ng liquid. And then, by the way, no, at 1 to 2, ito yung ideal natin. Ayan. At 1 to 2, magkakaroon ng, ano dito, work ng turbina. Then, from 2 to 3, ito yung dadaan na sa condenser, magkakaroon dito ng heat rejection. Ayan, no? And then automatically, no, kapag walang sinabi, we can safely assume that at point 3, the steam is saturated liquid, no? And then, upon reversible adiabatic pumping, 3 to 4, okay? So, ito yun, 3 to 4. So, nakita nyo, biglang nag-increase yung pressure. So, mula dito, pupunta dito. Di ba? So, nag-increase ang pressure dahil nagkaroon ng work ng pump po. Ayan. Okay? By the way, no, dito makikita, ito yung pressure line niya, no? Ayan, pressure line niya. So, ano makita nyo? P3 is equal to P2. Then, ito naman yung pressure line sa taas. P1 is equal to P4. And then, once na-achieve niya na yung condition sa point 4, papasok na uli siya sa ating boiler. So, magkakaroon ng heat addition, QA. Ayan, 1 to 4. Ayan, balik na siya sa saturated, superheated vapor. At point 4 nga pala, no, condition niya is compressed liquid, pwede din, or subcooled liquid, no? Since ginagamit naman siya interchangeably. So, iyan yung ating uh, Rankine cycle sa PD diagram. Now, kung ipa-plot naman natin sa TS diagram, which is ito yung lagi natin nagagamit sa klase. So, ito yung ating pressure line. Di ba? Ito, yan. Again, yung ideal natin dyan is 1 double prime, 2 double prime, 3, 4. Etong 1, dry yan. Bakit? Kasi yung point 1 naging saturated vapor. Ito naman, wet steam ang dumadaloy kasi yung 0.1 prime niya is wet vapor mixture. So ideally, condition ng steam at 1 double prime should be SHV, superheated vapor. Ito should be wet vapor mixture. 0.3 should be saturated liquid, and then ito ay compressed liquid, no? Ideally, kahit hindi na sabihin, no? Pero kung i-check mo yung condition, mas maganda, no? Para safe tayo at tama yung makukuha natin sa sagot. Okay, so meron tayong pressure line. Ayan, dalawa. And mabalik lang tayo dito, no? Mapapansin nyo, lagi mas mataas, no? Yung pressure ng mga equipment na nandito para dito sa diagram. Hindi naman necessary na ganyan yung diagram natin. Eh, ganyan ang pustuhan sa totoong buhay. So, in this case, ang may pinakamataas sa pressure lagi dyan is ito, no? Dito, yung sa boiler. And then, yung pinakamababa, of course, ay sa condenser. Now, mabalik tayo sa TS diagram. We have pressure line. O, ito. Itong line na to, kung i-extend ko to, ayan. So, P1 double prime is equal to P4. Bakit? At that point, yan yung papasok ng steam sa boiler and then lalabas, no? Lalabas na sa boiler. Then, at point 1, so mapapansin nyo, ito yung ating saturation curve. Siya ay superheated vapor, no? Kasi nasa labas siya. O nasa labas siya ng curve and nasa SHV region siya. So at point 1 to point 2, since TS diagram to, ayan, 1 to 2, pababa. Idea lang yung aking i-consider. Ay, ito. 1 to 2. Ayan. So this is S is equal to C. No? So ibig sabihin, S1 is equal to S2. Kaya vertical line yan. So ito yung pumasok yung steam sa turbina and then lumabas. And then nag-generate siya ng work, which is work ng turbine. Next, at point 2, no? O, ito yung pressure line niyan. O, ito. Ito yung pressure line nito. Okay, pressure line yan. Extend ko. So, this is P2, double prime, equals P3. So, at point 2, papasok na siya sa condenser, and then lalabas at point 3. So, ayan, no? So, ito ay P is equal to C process, and then nagkaroon ng heat transfer, heat rejection. Okay. Papansin nyo, tumama na siya dito sa saturation curve, saturation liquid curve. So, ito na yung point 3 natin. And then, 3 to 4, again, yan ay reversible adiabatic. So, S is equal to C. So, we can say that S3 is equal to S4. Ito pala, pwede ko extend dito, no? S2 double prime is equal to S1. And then, para mag-increase ang pressure, kailangan natin ng work ng pump. And then, from 4 to 1, pabalik tayo sa 1, yan ay P is equal to C. O, ito na nga. And then, magkakaroon ng heat added para tumaas ang pressure and temperature ng ating steam. So, yan yung ating TS diagram. Sa HS diagram naman, ito uli yung ating saturation curve. So, at point 1, ayan, obviously, that is superheated. Then, punta sa point 2. At S is equal to C. So S2 is equal to S1 double prime. Baliktad pala ako dito. This is S1 double prime. Karon ng work. Okay? Then, at point 2, papasok ang steam sa condenser. Labas at point 3, magiging saturated liquid siya. So, yan. Kita naman. At magkakaroon dito ng heat rejection. Heat rejection. Okay? QR. Or, ito naman, QA. Okay. At 3 to 4, o ito nga pala, itong linya na to, yun yung isobar or pressure line. So, this is P2 equals P3. Wala pala. Okay. O, dito yung ideal, okay, is, ganun pa rin, no? Double prime yan. 1 double prime, 2 double prime, 3, 4. Okay. Mabalik tayo from 2 double prime to 3. Yan. Constant ang pressure. Then 3 to 4. Magkakaroon ng adiabatic pumping. So magkakaroon ka ng S3 equals S4. Of course, need natin yung work ng pump. Then finally, from 4 to 1. Ayan, 4 to 1. So, yan ay constant pressure process. So we have P1 double prime equals P4, no? Then magkakaroon tayo ng heat added. Now, to solve yung mga problem, so kailangan natin malaman yung formula. Hindi ko sinasuggest na soluhin. Ang lagi ko sinasabi is mag-energy balance ka kada equipment, no? Para mas madali at hindi marami yung sasoluhin yung formulas. So, we can isolate each equipment, then perform energy balance. So, for example, ito. So, ito, no? So, meron akong boiler. So, obviously naman, so ito ay P is equal to C, no? Isobaric. So, ibig sabihin, P1 equals P4. Ito ay 0.4 to 0.1. Okay? So, dito natin pinainitan ng ating steam. So, of course, kailangan natin ng heat added. So, minsan, tinatanong sa problem, ano ang value ng QA? So, ito. Magkakaroon tayo ng energy balance. Energy in equals energy out. So, assuming that potential change in potential and kinetic energies are equal to 0, therefore, ano lang ang meron? So, ito. Pasok si heat added plus energy in terms of enthalpy. So, we have, of course, pasok si mass of steam dyan, ms times h4. So, ito yun. Pasok equals sum ng mga pumasok na energies equals sum ng lumabas. Ang lumabas naman is enthalpy at 0.1. So, we have QA plus ms h4 is equal to m sub s h sub 1. Or, finally, transpose natin to. So, we have QA is equal to ms times h1 minus h4. So, ito yung ating formula for heat added or heat gain for the cycle. Next equipment natin is the steam turbine, no? So, this is S is equal to C. So, we can say that S1 is equal to S2. So, upon leaving the boiler, yung steam natin, papasok naman sa turbina, sa steam turbine. Then, pasok dito, then lalabas at point 2. So, yan, papasok si mass of steam. And then, mag-generate siya ng tinatawag nating work ng turbina. So, again, energy balance. So, we have, papasok na energy is ito lang, ms times h1 equals ms times h2 plus work ng turbina. Pumasok, equals sa mga energies na lumabas. So, we have work of the turbine or is equal to mass of steam times h1 minus h2. Ideal pa lang ito, no? So, ibig sabihin walang irreversibility due to friction and heat loss. So, automatic, no? Pag may nakita kang problem, especially sa board exam, wala namang nabanggit, assume nyo na ideal Rankine cycle yun. Next, is the condenser. So dalawa siya. We have the steam side and then the coolant side. So kung babalik tayo dito sa ating unang diagram, okay, ito no. So yung circuit natin, steam circuit natin for steam side ay ito. Parang bali ito dito. Yung steam ang umiikot dyan. Okay? Now, dito naman yung coolant side. O ito. Dito. So, hindi naman palaging cooling tower yan. Pwedeng dagat yan or anything na makakapagpalamig ng ating coolant. So, magkakaroon kasi dito ng indirect contact na heat transfer. Ayan. So, bali dito sa part na to, dito papasok yung steam, 0.2, 0.3. O ayan, steam dyan. And then dito naman, A to B, pumapasok dyan ay coolant. Kalimitan, tubig na lang din, no? So, ayan, tubig. So, dito magkakaroon ng heat transfer. Anyway, so to solve that problem, balik tayo. So, condenser, steam side. So, steam side muna tayo. Diagram pa ako susunod, wala. So, steam side. So, galing sa turbina, ito yung 0.2. And then, this is yung 0.3. Pwede yung dito na lang ayusin natin. Ito. 0.2. Then, 0.3. So, ito yung ating condenser. P is equal to C. Okay? Kakaroon ng heat rejection dyan. Of course, pasok sa enthalpy 2, lalabas si enthalpy 3. So, MS. Energy yan, MS. So, energy in, energy out, pasok ito. MSH2 equals, lalabas ito, MSH3 plus QR. And finally, we have heat rejected in the steam side, that is mass of steam times H2 minus H3. Now, sa coolant side naman, okay, consider natin yan. Again, meron tayo lalabas na heat rejection or heat rejected. And then, we have, let's say, point A and then point B. Okay? So, energy in, energy out. So, papasok si mass ng coolant times, let's say, enthalpy at point A and then dito enthalpy at point B. So, mass ng coolant times HA equals yung lalabas na energy. We have mass ng coolant times H enthalpy at point B plus heat rejected. But we all know H is almost Cp times T. So, liquid form naman yan. So, okay lang. So, magiging MC Cp at point A, PA, no? Yung enthalpy natin equals MC Cp at point B, T sub B plus QR. O yung Cp at A equal lang naman sa Cp, specific heat. At constant pressure at A equal lang specific constant pressure at B. So, ito ay P is equal to C. So, yun na. Transpose lang natin to. So, and then collect similar terms. So, finally, we have QR equals mass ng coolant, Cp ng coolant, times T sub B minus T sub A or QR equals mass ng coolant, Cp ng coolant times delta T kasi kalimitan sa problem ang binibigay ay yung change in temperature na. Or minsan yun ang hinahanap, no? Yung delta T. Next, sa pump. Okay? So, kung meron tayong pump dyan, so pagkalabas ng steam sa condenser at point 3, pasok siya sa pump and then lalabas at point 4. So, this is S equal to C. So, ibig sabihin S3 is equal to S4. Para mag-increase ang pressure, kailangan natin syempre ng work ng pump. So, dito ay may enthalpy. Dito rin ay may enthalpy. Ang ibig sabihin ko sa enthalpy ay specific enthalpy. No? And of course, papasok syempre yung mass of steam. So, energy in equals energy out. No? So, we have papasok is work ng pump plus mass ng steam times H3 equals mass ng steam times H4 or work ng pump equals ms times H4 minus H3. Now, pwede nating approximate ang value ng work ng pump. Bakit? Kasi at point 3, di ba, ang condition natin, ideally, this is saturated liquid. At point 4, ito ay subcooled liquid. So technically, from 3 to 4, liquid siya. And we all know that liquid is incompressible. Tama? So kung incompressible siya, we can assume that specific volume is constant, no? So therefore, yung work ng pump natin, pwede natin equate sa word steady flow, which is equal to the integral of VTP from 3 to 4 differential pressure to, no? So integrate natin, we have V times P from 3 to 4. Or we have work ng pump is equal to V times pressure ng 4 minus pressure at point 3. At since siya incompressible, so volume equals volume at point 4 is almost equal to volume at point 3. In terms of specific volume, that is mass of steam times specific volume at point 3. So bakit ito na lang ginagamit? Kasi madali din siyang hanapin, di ba? Since ang point 3 ay specific ay saturated liquid, sa steam tables, pwede nating hanapin agad yung value ng specific volume. Kalimitan, no? So we have V sub 3 is equal to V sub F at point 3 or pressure 3. Okay? Ano ba tong VF na to? Diba? Sa steam tables, pag may subscript na F, automatic ibig sabihin ay saturated liquid. So finally, we have work ng pump is equal to mass ng steam times specific volume at 3 times P4 minus P3. Now, to approximate the value of enthalpy 4, okay, kasi nga at point 4, yan ay subcooled liquid. At kung makikita nyo sa steam tables na ginagamit natin, which is yun by Rankine and Keys, parang mahirap kasi hindi naman kompleto ang data. So mag-i-interpolate tayo. Minsan pa nga nag-double interpolate. So to avoid inconvenience, no? So pwede natin gamitin itong approximate value for enthalpy 4. So we have work ng pump, diba? Ito yung approximate formula equals sa ito talaga yung formula. Equate natin both. Cancel natin yung mass of steam. Okay? So ano matitira? Ito. So isolate natin si H4. So H4 is equal to H3 plus V3 times P4 minus P3. So we all know that V sub 3 is equal to specific volume at saturated liquid condition at point 3. So ito yung approximate formula ng H4. Take note na yung enthalpy, specific enthalpy of 4 is always greater than specific enthalpy at point 3 by this much. Okay. Now, for other formulas, so kung babalik tayo, no, pwede kang mag-energy balance sa buong system. Okay? So, ito yung boiler natin. Okay? And then, ito yung ating steam turbine. Then, ito yung ating condenser. And then, ito si pump. This is 0.3, 0.2, 0.1, 0.4. Of course, dito may work ng pump. Then, ito ay, of course, heat added. In this case, heat rejected. And then, work ng turbina. So, pwede tayong mag-energy balance. O, ito. In terms of heat, so ang ating network is QA minus QR. And then, in terms of work, that is work ng turbine minus work ng pump. Okay, cycle thermal efficiency. So, we have efficiency, as we all know, definition is output divided by the input. So for the cycle, ang output ng ating cycle is yung tinatawag na network. and then yung input is energy chargeable to the cycle. So, ang ating network or W sub net over E sub C, energy chargeable to the cycle. Ang energy chargeable to the cycle is yung ating heat added to the boiler, no? And then palitan natin 'yan. So technically, no, we have thermal cycle efficiency ng Rankine cycle is work net over heat added, no? However, nakuha na natin tong work net. So pwedeng QA minus QR over QA or pwede rin ito na lang, no? Work ng turbine minus work ng pump over QA. Ano ba ang work ng turbine? Mula sa formula natin kanina, we have mass of steam times H1 minus H2. Work ng pump, that is what? Mass of steam times H4 minus H3. And then ang QA natin, kung babalikan mo, is mass ng steam times H1 minus H4. So, palitan natin mga corresponding formulas. So, ayan. And then, pwede natin i-cancel out si mass ng steam. And then, simplify natin. Finally, in terms of specific enthalpy, we have cycle thermal efficiency of H1 minus H2 plus H3 minus H4 all over H1 minus H4. So, madali lang tandaan kasi pag sunod-sunurin mo, 1, 2, 3, 4, then alternate lang yung sign, positive, negative, all over H1 minus H4. So, yan yung ating Rankine cycle.